Now, I know we left off with some trig functions the other day, but I would like to, and I'm gonna cut off my video so I can kind of save some bandwidth. So just give me a second. Turn the video off. There we go. All right. So turn on my handy dandy. Oops, that's the wrong class. Let me see if I can just delete that. Yep. Okay. And we are going to start with some substitution. Okay. Before I get started with substitution, let me just remind everybody. Let's go here. Just reminding everybody that there's several parts to integration, and they are as follows. 1, you should be able to do the basic power rule. 2, you should be able to do anything having to do with pulling out the constant. So if there's 1/3 x dx, then you should be able to pull that constant out like that. And you should be able to do algebraic versus calculus. In other words, if you can't do it by calculus, you might be able to do it by algebraic. And we did a couple of those the other day. 4, and that's what we're going to go over today, and that is basically called substitution. And then 5, trig. Okay. Now, after that, I'm going to test you on some of chapter 6, which will be and I might put the first part on this test, or I might just make it a separate test. I don't know. And that is the area between curves. I haven't decided what I'm going to do yet there. Okay, so this is very important that you understand how to do this before going into Calc 2. So we're going to work on substitution today and maybe get into a little bit of trig. All right, with that being said, let me go ahead and shut this down. And I found out I've got the updated versions that if I wanted to, I could actually draw on top of my drawing here. Oh, there. If I wanted to, I really haven't figured out why I would want to, but I'll figure it out eventually. All right, so let me minimize that, and let's go back to the whiteboard. And y'all let me know if it's lagging or doing anything funky, okay? Miss Hart, I know you'll let me know. All right, the first one we're going to go over is, let me get rid of that, is the antiderivative of the square root of 3x plus 2 dx. And something happened to my, I'm going to let you write that down. I want you to go ahead and rewrite it. Of course, you're not going to write it with a radical because radicals and calculus don't mix. And while you're doing that, I'm going to recalibrate. I thought I had it calibrated. I must have hit something, so give me a second. Okay, it's not going to let me calibrate. There we go. Yep, something happened. It's going to take me a second to calibrate it. Gotta go the opposite way. Went too far that time. There we go. Sorry about that. And now back to the whiteboard. So I'm going to rewrite this as the antiderivative of 3x plus 2 to the 1/2 power dx. Now, when you're looking at substitution, you want to go over to the right-hand side and you want to pull out the most complicated part. And you want to focus on this little blank right here, because you're going to have to add something here and here to make it work. Now, sometimes you won't have to, but most of the time you're going to have to add something. All right? So let me erase this right here and make that a little bit bigger space. So I'm going to go over here and make u equal the only thing I can make it equal, and that is 3x plus 2. du is going to be equal to 3 dx. Well, we have a dx.
Priority 1 message coming in.
We just don't have a what? We don't have a 3. So I'm going to add a 3 to the integration, and that means I got to add a 1/3 out here. Now, somebody tell me what 1/3 times 3 is.
1.
1. Now, what that gives me inside of the integration now, it gives me u du. Okay? Because this is u and this is du. So I've just made my integration follow the scheme of u du. Is that your objective when you are trying to do substitution? Yes or no? You got a 50-50 shot.
Yeah.
Yes, it is. That is exactly what you're trying to do. You're trying to make u du possible. That's what you're trying to get in some form, some way. So now I can move on, and this time I can rewrite my integration like this. 1/3 antiderivative of u to the 1/2 du. And now all you have to do is take the antiderivative of the u to the 1/2 power, and that's going to give you 1/3. Okay, I don't know why my why it's going crazy down there on the bottom. I don't know why that's happening. 1/3 times u to the 3/2 over 3/2. Now, I did skip a step there. You got to do 1/2 plus 2/2 over 1/2 plus 2/2. I skipped that step. And then that's going to give you 2/3, because I'm going to bring that 3/2 up. That's going to be 2/3 times 1/3 times u to the 3/2.
Priority 1 message coming in on secure channel.
I don't know who that is. It keeps texting me. All right, so that's going to be 2 over 9. U to the 3/2, so I'm going to write that to the 3/2 plus C. And what is U? 3x plus 2. And that's your answer.
Someone wants your attention.
I'm sorry, what'd you say?
Someone really wants your attention.
I know. Which is probably my daughter or my son, one of the two. Now, I do expect people to have questions here. And the number one question, I don't even know what that is. Something about coronavirus, and I don't even wear a mask, so to hell with it. I'm sorry. Didn't wear a mask for the flu. I don't know why I got to wear a mask for this. Oh, yeah, that's right. The flu just disappeared. I'm sorry. We don't have the flu anymore. It just disappeared. All right. So I'll tell you where the biggest question comes into play. The biggest question is, you see the red 3 and the red 1/3? When I come down, students always go, well, what happened to the 3?
That's exactly what O'Quinn said.
What?
It's exactly what O'Quinn said.
Okay.
So what happened to the 3? Quoted.
Okay. The 3 is part of DU. Okay. Let me show you this. Solve for DU. Solve for DX over there. I'm going to go over here. Let's see if I can hit a blue pen. I don't want orange anyway. Orange don't show up. Let's go with this blue right here. Solve this right here for dx. Dx will be equal to du over 3. So you actually could put this dx right here. You could say du over 3. And what happens to the 3's? Now, there are some teachers that show it that way. I don't, okay? Because to me, that's more confusion. And you will see the problems that I'm doing. I put that blank there and I put a blank outside because that's what's going to happen. The 3 is going to cancel out. Okay? And that leaves us with u du because the du is the only thing left. Just take my word for it. But that's the biggest question that teachers get in calculus. Where did the 3 go? And if you multiply, if you solve for dx and you get du over 3, and you plug that du over 3 back in, you see that the 3's cancel out and you're left with du. All right, so let's do another one. And that right there is a test question. So you might want to, all these that I'm showing you are test questions. Let's see, next, how do I do this? I hit that and that. So antiderivative of x times 3x squared minus 1 to the 4th power dx. Now I'm going to tell you the way I learned to do this. Dr. Harden, he didn't tell me how to do this. I came up with this. Whenever you're going to have to deal with substitution, and I told you what gives away the substitution. Let me tell you, I can use this now. Now that I've got it on a new computer, I can hit translucent, and it puts a little check there, so I know I'm right. Well, I didn't got it thick enough. Sorry. There we go. What gives away the substitution? The what?
Parentheses.
The parentheses. When you see a parenthesis or a radical or maybe an e to the 4x, when you see a complicated and you cannot use, can you use algebra here? If you like whips and chains, yeah, because you've got two shortcuts. 3x minus 1 to the 2nd power times 3x minus 1 to the 2nd power times x. If you want to do that, knock yourself out. And I'm just gonna go over here and we're gonna write 2 or 3 things down that tells you. Y'all have to excuse me. 1, parentheses. 2, radicals. 3, algebra doesn't what? Help. When all 3 of those, when you got one of those 3 things, chances are you're going to use substitution. And I'm going to rewrite, now that you know that you need substitution, I'm going to rewrite this. Now, luckily, you don't have anything to choose but 3x squared minus 1. So u is equal to 3x squared minus 1. What is du? 6x what? dx. Oops, I'm sorry. What do we have? We've got an x dx. So what do we got to put into the, what do we got to put in there? I'll use my blue here.
So wait, why?
6 here and what? And 1 6 there. And now I have u to the 4th du. And now I can do 1 6 antiderivative of u to the 4th du. Now again, if you wanted to solve this for dx, I'll solve it for you. Dx is equal to du over what? 6x. Plug that in for dx, and I'll do that for you. Let's do that in red or magenta. So dx is equal to what? Du over what? 6x. And what happens to the 6x's? They cancel and you're left with du. So however you want to do it, knock yourself out. Okay? I really, I try to show it the best way or the easier way. But if you want to do the solve for dx, that's fine. So what is the antiderivative of u to the 4th? Okay, I don't want y'all, that's not rhetorical. I want y'all to actually interact with me.
I was asking a question earlier and you didn't hear me.
I'm sorry. Go ahead. Go ahead and answer.
Well, I don't know the answer to that. I'm confused because about the, like, why is the X in black since du is equal to 6x? I mean, did you just write it in black or?
Okay, look at the front, look at the top. There's an X out in front.
Yeah, so that's just gonna automatically go over there?
I moved it over to the right because it's going to go with the dx. That's the way I do it. That's the way Hubert does his substitution. I move whatever's in front of the parentheses, I move it over there to the dx because I know that something is going to be multiplied by dx. I just don't know what until I actually do it.
Okay.
So I just, between the first and the second step, I just put 2 blanks in there and I move the x over to the dx.
Okay.
You see? I just took, I'm sitting down right now, so I'm not at the board. I just took this x.
Yeah.
And I put it right there. And I put a blank there and there.
But what if there was like an actual number?
Well, that's a totally different animal. We can't do that. That's why I'm giving you these different examples.
Okay.
Okay, so don't try to corner yourself by saying if. Let's just do these examples and you'll see the pattern. You'll see it.
Okay.
Okay, so what is the antiderivative of u to the 4th? Power rule. What's the antiderivative?
U to the 5th divided by 5.
Thank you. Who was that? I can't see who said that. Thank you. U to the 5th over 5. So this gives us 1/6 times u to the 5th over 5. And that gives us u to the 5th over 30. Well, plus c. I'm just going to let y'all plug back in, okay? I got my orientation and my, what do you call it? Not collaboration, but calibration. I've got the calibration a whole lot better. Does it look like it's a whole lot better from y'all's end?
Yeah.
Okay, so that's going to be, I'll tell you what the final answer is. 3x squared minus 1 to the 5th power over 30 plus c. So if you wanted to do the derivative, excuse me, I just told you that, let me go over there and write it. Now I'm rolling.
So you don't plug the u back in?
Rolling. What?
You don't plug the u back in?
Yeah, that's what I just said. That's the final answer. You take 3x plus 2. Let me do it. That's going to be, I'm running out of room. That's going to be parentheses 3x plus 2, well, I meant 3x squared, sorry, minus 1 to the 5th power over 30 plus c. 3x squared minus 1 to the 5th power over 30 plus c.
Okay.
Now, take the derivative of that. Okay, I'm going to erase some of this. Let me find my eraser because I can't hardly see it. And I'm going to erase some of this over here. And it didn't do what I wanted it to do. There. All right, let's take the derivative of 1/30 3x squared minus 1 to the 5th power with the chain rule. Somebody do that. What do you get? What are you going to do first? It's chain rule, so what are we going to do? You're going to bring the 5 out front, Hubert. That's right. 5 times 1/30 times 3x squared minus 1 to the 4th power. What's the derivative of 3x squared?
6x.
6x times 5 is what? 30x over 30 times 3x squared minus 1 to the 4th power. The 30 cancels, and that leaves you with x, parentheses, 3x squared minus 1 to the 4th power. What do we have to begin with? X times 3x squared minus 1 to the 4th power. So that's correct. All right, let's hear it. Let's hear something.
Makes sense.
That don't sound too convincing from you, Miss Hart.
I mean, I believe you.
I believe you. I just don't know about this substitution. Is that what you're saying?
No, I mean, I get the substitution
Okay.
stuff. I'm just a little confused about the, like, what's out front. Still, I need to see another one just to pick up.
Okay, you're right. I've got about 10 or 15 here, and we ain't even, I'm gonna keep on showing them to you till you get the pattern. All right, here's a nerd. The antiderivative of 4x times x squared plus 5 to the 3rd power dx. Now, first of all, I'm going to rewrite it. I'm going to rewrite it because I want that 4x over there near that dx. So, antiderivative of x squared plus 5 to the 3rd power 4x dx, and I might have to put a blank right here. I don't know, and I'm going to put a blank right there because I don't know. I got to see. So what is u? U is going to be x squared plus 5. Somebody tell me what du is. 2x dx. What do we have? That means somebody in the class needs to answer. We want 2x dx. What do we have?
4x dx.
So how do I make that 4x dx turn into a 2x dx?
1/2.
Multiply by 1/2. If I multiply by 1/2 in the integration, what do I need to multiply on the outside?
2.
What?
2.
2. What's 2 times 1/2?
1.
1. So now I've got 2 u to the 3rd du. But I'm going to put a step in here. I'm going to put a step right in here. I'm going to put 2 antiderivative of x squared plus 5 to the 3rd power 2x dx. And if you wanted to, you could go over here and say dx is equal to du over 2x, and plug that in right there. And what will happen to the 2x's?
It goes away.
They cancel, and now you're just taking the antiderivative of u to the third. So 2 antiderivative of u to the third du. And somebody tell me what the antiderivative of u to the third is.
U to the fourth over
U
4.
to the fourth over
4.
4. That's supposed to be a 4, but something happens when it gets down there. I don't know if it, let me redo that. Something goes quirky when it gets down here to the middle of the board. I don't know if my arm gets in the way or what. Let me try to move to the side. 2 parentheses u to the fourth. Yeah, it must be my arm. U to the fourth over 4 plus c. And then that's going to equal 1/2 u to the fourth, 1/2 u to the fourth plus c, which is 1/2 x squared plus 5 to the fourth plus c. Now you could do the chain rule in your head. What's 4 times 1/2?
2.
X squared plus 5 to the third times 2x. 4x, x squared plus 5 to the third. And that's what we got at the top. All right, now here's one to challenge you. Now I know half of y'all are probably going to stare at it, right? That's what you do when you don't know what to do. Just sit there and stare at it and throw down your pencil real hard, right? Nobody's going to give me any kind of input on that.
That's what I would do.
That's what I did.
Don't throw it down. I just put it down.
This, you gotta, when you get irritated, you gotta throw it down, and you get good at it, you can make it pop. Well, I can't make it pop anymore. Oh well. Some of y'all might can make it pop. You're better with a pencil. All right, so here we go. The antiderivative, I'm gonna have to write it because I can't write with a mouse. The antiderivative of x to the third e x to the fourth. Oh shit. Hold on. I went too far up. Let me try that again. X to the fourth dx. Now, before you quit, and before you don't even try, I'm going to rewrite it. Blank. And then e to the x to the fourth, x to the third, dx. I just told you what I was going to make. I'm telling you right now what you're going to make u equal to. Anybody got a guess?
X to the fourth.
X to the fourth. U is equal to x to the fourth. Not all the time, but most of the time, your u is going to be your highest degree. Most of the time. So that x to the fourth is your highest degree. So I'm going to make u equal, over here, u equal x to the fourth. So what is du? 4x to the third dx. What do we have?
X to the third dx.
So what do we need to add to our x to the third dx?
A 4.
Add
Or, you know, multiple it. Don't
Okay.
get technical on me.
okay, I'm just trying to make sense of
You
this.
put 4 with that x to the third, right? That's supposed to be black. Hold on a minute. I don't know how that turned black on me. Okay, I'm going to put a 4 right here. So what am I going to put on the outside? 1/4. Now, if you want to, I'm going to go over here. And I'm going to solve dx, which is dx is equal to du divided by 4x cubed. So if you wanted to cancel the 4x cubed, there it is. And basically, you're left with 1/4 antiderivative of x to the fourth dx, du, or I'm sorry, e to the u, sorry, messed up. E to the u e to the u du. Now, I'll tell y'all a little trick learned in the war. What is the derivative or the antiderivative of e to the x?
E to the x?
The x. So what is the antiderivative of e to the u?
E to the u.
E to the u. So your answer is 1/4 e to the u plus c. And what is u? X to the fourth, Hubert. Thank you, class. I'm going to do something I haven't done in a while. I want to see some numbers, 1 to 10. Okay? 1 being, I have no earthly idea what's going on. And 10 being, I'm getting it. So let me see them. 8, 6, 5, 7, 8. Okay, I don't see anybody going negative 0.5. So, Mr. Luckner, come on. You can do better than a 3, can't you? Oh, I have some catching up to do. Just go ahead and face it, Mr. Luckner. You might as well just quit, man. It's just inevitable. I'm just kidding, of course. Okay. So it looks pretty good, except for Super Dad, and Super Dad's got some catching up to do. So let's do a nerding. What? Oh, okay. Okay. I'm looking at some of the conversations. All right, so let's do a nerding, and let's make this one even more discouraging. How about that? Let's make it discouraging. Don't worry, I'll get some more for y'all, and I'll try I'm going to try to put some homework up. I'm really not liking that homework. Anybody have anything to say about the homework that's assigned? To me, it's like floating. It's like out there. What do y'all think?
You keep complaining about it, so I don't want to try it.
Okay, well, it's not difficult. It's just not pertinent to what we're doing. All
I
right, here we
haven't
go.
started it yet. So what are we supposed to be doing any of it, or can we wait?
Well, you need to be looking over it and trying some of it. Yeah. I mean, it doesn't hurt. I mean, just look over it. 8x square root of 40 minus 2x squared dx. Now, the first thing I would do is I would rewrite it not only with the radical, but I would also rewrite it because I want that 8x to be where? Beside the dx, Hubert. That's right. All right, go to it. I'm going to let y'all do this one. I'm going to put the timer on. Give you 2 minutes. And if you can't do it in 2 minutes, then that means that we're all just going to hell in a handbasket. That's what it means. And that's 2 minutes. So y'all should be through with it.
I gave up after about 10 seconds.
You gave up. Okay, good. I'm glad to hear you giving up. That's a good thing. It's a joke, people. Okay. I'm gonna do this one on the handy dandy Word document. There we go. So we've got the antiderivative of 8x times the square root of 40 minus 2x squared dx. The first thing I'm going to do is I'm going to rewrite doing two things. I'm going to rewrite using 40 minus 2x squared to the 1/2 power, and then blank 8x dx. Put a blank here. Everybody with me? Now everybody should be able to do this. Okay, make me proud, all right? Now, somebody tell me, what am I going to make u?
40 minus 2x squared.
Okay, I'm going to say negative 2x squared plus 40 because I've never seen people write like 40 minus 2x squared until the last couple of semesters. These books, I don't know why. I'm 53 years old, and I went to school, when you're 8 or 9 years old? When do you go to first grade? I never have seen, in 40 plus years, I never have seen people write 40 minus 2x squared. So I don't know. Maybe it's something to do with, I don't know. Du is equal to what? What's my du? Negative 4x what? Dx. So I need to make my 8x look like negative 4x dx. How do I do that?
Negative 1/2.
Negative 1/2. Good job. Who was that?
Preback.
Okay. You're not giving up on me, Mr. Preback.
No, sir, not yet.
Dadgummit. That means I gotta hit you harder. All right. So now I'm going to rewrite 40 minus 2x squared to the 1/2, and that's going to give me a negative 4x dx. Now I've got u du. So now I can rewrite it to antiderivative of u to the 1/2 du. Because this, and sometimes I do this and it kind of helps y'all. This is that. But I couldn't do this. I couldn't do this in pink until I had the negative 4x. And I didn't have it up here. So I had to make it. Now, one question that students always ask, especially if they suffer from RAD a little bit, when are we ever going to use this? One of the reasons for calculus 1, 2, and 3, not to mention statics, dynamics, and thermodynamics, is to manipulate a problem and manipulate it and tear it apart in several different ways to when you put it back together, it's as good as it was or it's even better. That's the whole point of problem solving, okay? That's why you do not want to go across a bridge, across a river, built by somebody that's had probability and statistics and no calculus. Okay, that's why, because they take something apart, either mentally or physically, and they manipulate it. They put it back together a different way, and it either makes it better or as good as it was. And that's what you're doing. You're manipulating this. Calc 1, 2, 3, DiffEq, statics, dynamics, and thermodynamics. They all teach you how to manipulate a problem. Okay, so it's training. Nobody's ever going to walk up to you and ask you to do this unless you're a math teacher. But they will ask you to manipulate and solve problems if you're an engineer or a science person who's solving problems. Okay, research. All right, so that's going to be 2 parentheses u to the 3/2 over 3/2. Which is equal to 2/3 times 2 u to the 3/2, which is 4/3 u to the 3/2 plus c, which is 4/3 parentheses 3/2 plus c, and that's going to be negative 2x plus 40. And we could easily do the chain rule and take the derivative of this. Let's do that. I'm going to leave it on there for about 30 seconds. And I want you to take this right here, and I want you to take the derivative of that function and see if you get this right here. Hopefully everybody's got to that point. Sorry. So we're going to do a check. (4/3) negative 2x plus 40. Is it 2x squared? Yeah. Mr. O'Quinn, where are you at? You got to fix your dadgum computer. Okay, let me make sure I did that right. That's supposed to be 2x squared, right? Yeah. Okay, 2x squared, what, to the 3/2? All right, so here we go. Chain rule. 3/2 times 4/3 negative 2x squared plus 40. What is 3/2 minus 2/2? So 1/2. And what is the derivative of negative 2x squared plus 40?
Negative 4x.
So that's going to be negative 4x over 1, 3 over 2, 4 over 3, square root of negative 2x squared plus 40. 3's cancel. Let me get my red pen so we can do this legitimately. Reds cancel. 2 will cancel with that 4 and make a 2. And then what is 2 times negative 4?
Negative 8.
Negative 8x times the square root of negative 2x squared plus 40. Let's see if that's what we started with. Look at there. It's a miracle. It's supposed to have a negative. What happened to the negative? Okay, I got something wrong somewhere.
You have it negative 2x instead of the minus 40, you have plus 40.
Okay, show me where you're talking about.
You earlier you switched the sign because you said that we'd never have a minus 40 as like the dx or whatever on the side.
It's not
Yeah.
minus 40, it's still plus 40. It's 40 minus 2x.
Yes, it's a plus
It's still
40.
the same.
It's a plus 40, but I've got an error somewhere. Mr. O'Quinn, see if he can find it. I've got an error somewhere because it's supposed to be a positive 8x. Okay. I think it's in my check. Let me look right quick. I'm trying to find it. I know my answer's right. 4/3 negative 2x squared plus 40. I think I've got an error somewhere in here.
You said it's negative 4/3?
It should be a positive 8x. I've got a negative 8x. So that means that negative right there is screwing up things.
But that is going to be negative because it's
So there must be there's got to
4x.
be another negative somewhere.
What is the other one? What is, like, where's that for? Is that 4/3 negative on the other page?
Yeah, that's it. I didn't write down. Yeah, that's it. Supposed to be negative. Thank you, ma'am. That's supposed to be a negative. Okay, negative 4/3 would make that a negative right there and a negative right there. There we go. Thank you, Miss Hart. Okay, thank you on that. So you see that your answer will be the same. Hopefully y'all are starting to see the pattern. And it's a whole lot easier when you rewrite the problem and you have the problem, you know, with those two blanks it makes life a whole lot easier. Antiderivative, I know it's 410. Let's do one more, and I'll do the trigs, because the next problem is a trig problem. So this will be the stopping point. We'll do trig tomorrow. Antiderivative of x cubed over 2 plus x to the 4th to the 2nd power. And of course, you would do what on this? Quit. Now, which one has the highest degree? Okay, well, I'll wait for y'all to answer.
I thought I was talking. I had my mic muted. I'm sorry.
That's all right. 2 plus x to the 4th. Which one has the highest degree?
Is it the x to the 3rd?
X to the 4th. That's the highest degree, the highest exponent. So you're going to make u equal x to the 4th plus 2. What is du? 4x to the what?
3rd.
Oh, what do we have? We have x to the 3rd. I need to put my blank up there, or I can bring it over here. So, parentheses, let's do this again. 1 over 2 plus x to the 4th to the 2nd power, x to the 3rd dx. Okay, so what do we need? I'm going to start assigning people to answer me.
Just the 4?
That's it. And if you put 4 on the inside, what do you got to put on the outside?
1/4?
1/4. So now we have 1 over u squared du. So 1/4 antiderivative 1 over u squared du. Because what is 4x cubed dx? Du. Now you just need to rewrite as a negative exponent and finish it out. All right, finish it out. I want you to finish it out, and then we're going to check it, or I'm going to get you on the way to checking it. Because you're going to have to use the quotient rule. Well, I don't know if you will or not. I don't think you will. You may. So that's going to be 1/4 u to the -1 over -1, which is equal to -1/4 u to the -1, which is equal to -1 over what? X to the 4th plus 2?
Yeah.
Okay, now I want you to take the derivative of that and see what you come up with. Actually, you can use the chain rule, write it to the -1 power, put the -1 out front, you won't need the quotient rule. So I'm going to take it to the next page. And this will be the check. I'm going to put the problem right there in the top right there.
So look, if you put your like plus C in these, because we haven't been checking them with the plus C.
Okay, remember, what are these? Are these finite or are these infinite? These are infinite. They don't have numbers right here. They don't have, so they're plus C.
Yeah, so wouldn't that be like when you get to the end and you take the derivative, that would add 1 to it, right?
No, you don't. Okay, the plus C is only telling the reader or the person reading it that this is in the family of these functions. Okay, remember me showing you f of x is equal to 2x squared plus 6, and f of x is equal to 2x squared minus 7. What's the derivative of this one?
4x.
4x. What's the derivative of this one?
4x as well.
So you have to add the c, because this is saying, this right here, that c is saying it's in the family of
There's
2x
something else
squared,
there.
but we don't know what the y-intercept is.
Okay. I
That's
just
what that says. Okay, now if you want to check this, you just check this right there, and you will get this right here. Okay, that's
okay,
what.
right. Okay, I get it. I get it.
All right. So here is our answer. So we're going to check it.
What happened to the 4?
What happened to the what? Thank you.
It's 1 negative 1/4 u
Yeah,
to the
supposed to be right there. Thank you. Okay, so that's going to be negative 1/4. And then I'm going to bring this up. That's going to be x to the 4th plus 2 raised to the what? Negative 1 power. Everybody with me? That's our function. So now let's use the chain rule. Negative 1 times negative 1/4 is what?
1/4.
1/4. X to the 4th plus 2 to the negative what? 2. And what is the derivative of x to the 4th?
4x to the 3rd.
So 4x to the 3rd over 4. X to the 4th plus 2 to the negative 2. The 4's cancel. And you're left with x to the 3rd over what?
X to the 4th plus 2.
X to the 4th plus 2. Look at there. Let me bring this over here so y'all can see. There it is. And that's how you check them. So hopefully you're starting to feel a little bit better. Are you starting to see the pattern with the blanks?
Yeah.
Okay. Now don't let it get cold. Now I do know, I'm going to look right quick because I think, somebody look at your outline. Isn't the, hold on, I'm trying to pull up your class. I think 5.5, doesn't it say substitution? Okay, nobody's looking. I'll look. 5.5, the substitution rule. Let me go look at your homework. If I can find it. There it is. I took the stupid ones out, the ones that nobody knows the answer to. I took those out. Let's see, 5.5. They're teaching you to substitute right here. Let me get you, okay, let's see. They're teaching you how substitution works. This is algebra. This ain't, let's see, substitution. There we go. Okay, so I'd start with number 7 or number 5. I'm not worried about that other stuff. There's your one right there. What is the derivative of x squared plus 1?
2x.
So do you have to add anything to this one?
No.
No. So what do? Well, what was it? That was the antiderivative of 2x parentheses what? X squared plus 1 to the fourth. X squared plus 1 to the fourth dx. I'm going to rewrite it using the Hubertism. X squared plus 1 to the fourth 2x dx. U is equal to x squared plus 1. Du is equal to 2x dx. What do we need?
Nothing, they're saying.
Nothing. So put a 1 there, put a 1 there. So you've got, now we've got u to the fourth du. The antiderivative of u to the fourth du is what? U to the fifth over what?
5.
And you got that 1 out there. If you want to get technical, there you go. And that's going to be x squared plus 1 to the fifth over 5 or 1/5 x squared plus 1 to the fifth plus c. So I would start with number 5, and maybe I doubt very seriously that they're going to keep them that good. They're probably going to mess it up. So let's see. That's number 5. Let's see what they do, and then we'll finish. Where's my problem? There it is. Okay, that one's good. Okay, that one's good. That one's good. What are you going to make u equal to? Where's your highest x? 8x minus 3. So u is equal to 8x minus 3. What's the derivative of 8x? 8 dx. You got to have an 8 in there, so you got to have a what out front? 1/8. U is equal to 3x plus 1. What's the derivative of 3x plus 1? 3 dx. I need a 3 here. I need a 1/3 out front. Same thing here. You don't need anything because you got 2x dx. So that one's just going to be u du. So that's going to be u to the 97th power over 97. Oh, they're just asking you what is u. So some of these are real easy. Here you got the 6th power. I would use that. That's a good problem right there. That's a test question right there. Number 19 or number 10. All right. So y'all can work on 5.5 at least. Y'all with me?
Okay.
Okay. They don't sound too promising, but maybe y'all will get started on it. And look over your other ones too. There should be some power rules in there with the with either 5.3 or 5.4, somewhere in there. I'll adjust if needed. Don't worry about that. Let's go with turning off the recording and turning off the presentation.